Okay, now for the last part of matrices, we're going to talk about the inverse of a matrix. And then I'm going to write a to the power minus 1. Okay, this little power minus 1 is how we identify an inverse, right? So if our matrix was A, the inverse is A to the power minus 1. If our matrix was B, then the inverse will be called B to the power minus 1. It's just notation. Okay, so now if we have a matrix A, if A is equal to A, B, C, D, then the inverse, which is A to the power minus 1, is equal to 1 over the determinant. Then the first thing you do is that A and D switch positions. So D comes up, A comes down, right? And then these two don't switch positions, they simply change signs. So whatever was positive becomes negative, whatever was negative becomes positive. So we can show that by putting these negative signs here. So I want us to be clear here. Let me use another color. These two switch positions. Okay? These two do not switch positions. They simply change their signs. Whatever was positive becomes negative. Whatever was negative becomes positive. In this case, they were both positive. Both became negative. Okay, so let's have an example to show. If we have a matrix, perhaps 2, 3, 2, 5. If you want to find inverse, the first thing we need to do is to find the determinant. So the determinant is equal to 2 times 5 minus 3 times 2, which is 10 minus 6, which gives you 4. The inverse, therefore, becomes 1 over the determinant. Our determinant is 4. And remember, we play that game. These two switch positions. 5 comes up, 2 goes down. These two change signs. They were both positive in this case, so in the inverse they become negative. So this is your inverse. You can feel free to leave it like this. So this brings us to the end of the topic. You can attempt the questions on the inverse.